the story so far. When molecules escape from a liquid, they spread out in all directions to form a gas or vapor. This process is called evaporation, the change of state from a liquid to a gas. When gas molecules are cooled, they go slower and crowd together more densely to form a liquid. This process is called condensation, the change of state from a gas to a liquid. And now, expansion and contraction. If you blow a balloon only partly full of air and leave it in the sun, it will get quite a bit bigger. If you take another balloon and blow it up as hard as you can, and then leave this balloon in the sun, it will very likely burst. Why? Why do balloons get bigger and sometimes even burst if they get hot? Because the air in a balloon, which is, of course, a gas, consists, like all gases, of molecules flying about in every direction. When you've got zillions of gas molecules doing this, they push quite hard against the inside of the balloon. That's why its skin is stretched so tight. When the sun makes the molecules hotter, they go faster, so they bounce harder and more often against the inside of the balloon. This pushes the balloon outwards and makes it bigger. Hot molecules take up more space than cold molecules. It's as if a lot of angry wasps were buzzing about inside the balloon. The hotter they become, the faster they buzz. And the further out they push the sides of the balloon. All of which boils down to saying that when a gas gets hot, it takes up more space. It expands. On the other hand, if you let a balloon get very cold, the reverse will happen. It will become quite a bit smaller. Because the colder the air molecules become, the slower they move. And the less they push against the inside of the balloon, which can now squeeze them into a smaller and smaller space. Cold molecules take up less space than hot molecules. The colder the wasps become, the slower they buzz, and the less room they occupy. In other words, when a gas gets cold, it contracts. Do solids and liquids also expand when they get hot and contract when they get cold? Well, you'll remember that if solids get hot enough, they melt into liquids. And the hotter liquids get, the more quickly they evaporate into gases. That's clear enough. But what's not so obvious is that before the change of state takes place, in fact, as soon as the solid or liquid starts to get warmer, it does begin to expand a very small amount. This is because the faster the molecules move, the further they pull apart from each other, both in a solid and in a liquid. That's why a space is always left at the top of bottles to allow for expansion in case their liquid contents should become too warm. A bottle should never be filled to the top, in fact, because if the liquid inside it gets too hot, there's even a danger of the bottle exploding. Can you think of an everyday example of a solid expanding and contracting? Well, what do you think causes that ka-thump, ka-thump noise when a car drives over a bridge? It's the wheels running over the spaces that have to be left between the slabs of concrete in the road to allow for expansion in the summer and contraction in the winter. So now you know not only why cars go ka-thump, ka-thump on bridges, but also how to prevent bottles from exploding and balloons from bursting. Or do you?